S9. You don't have to worry about too much. So we have such a different ways of accessing the data. The linear search is a full table scan. So it doesn't matter whether sorted or not sorted. So just scan from the beginning to end. If you find the data, return. So binary search and using primary index or the secondary index, this S4 and 5 is for multiple records. Also, in case of the combined one, we can separate and find the best one, actually, fastest one, and so on. The next part is the join. So mostly, the query optimizer consider two main parts: how to access each table, okay? Then how to combine multiple tables, which means the join operation. So for the join operation, so these are the example. Employee and department joined with the join the condition. DNO is equal to D number, or the manager social security number is equal to the social security number. It's a join condition. There are different types of join. First, employee and department. So we are going to join with the DNO is equal to D number. So employee as the DNO, department is the D number. Nested loop. What does it mean, nested loop? So two full loop, right? This is a nested loop. For each record of employee, find which one is matched for all. We do not use any index. And next, this one. And next, this one. This is called nested loop join. Okay? It's kind of brute force way. Nested loop join. However, if we have something faster way to find the department, like the index or D number or social security number, that is sorted or that is indexed, we can use such a sorting. So which means for each DNO using D number index. And we don't have to scan all the table, instead find it directly using index. That is called single loop join. How can the query optimizer determine whether nested loop join or single loop join? You need to check, query optimizer check whether there exists the index information. Index 1. If there is an index, we'd better use single loop join. Otherwise, the nested loop join. So that is the join. There is another one, it's a sort merge. Sort merge means if we access the join the two table, why don't you sort the data in the left hand side by DNO 1, 1, 1, 2, 2, 3, 3, and sort this data by D number 1, 1, 1, 2, 2, 3, 3. This is a key, so 1, 2, 3, 4, 5. Okay, so sorted. Then next step is the merge from the top or lowest number from the top. Whether match it. Then move next. Match, match. Then this one is match it, match it. The next match it, match it. Like that. We don't need indexing structure, but we can speed up to join the data. If you, in case you have very fast sorting algorithm. At the time, this one is working very well. Sort merge join. So first, nested loop join is the brute force way from outer table to inner table. Match all of it. Single loop join, in case we have the index for the inner table, okay, driven table, we can use such an index. So we can using only one loop, for loop for this one, and using index. It's a single loop join. The third one is a sort merge. We can sort the data, then merge it from the beginning. in case we have very fast sorting algorithm. The next one is a hash join. Hash join means, anyway, I need to explain about it. So what time is it? 2:47. So 3 more minutes. Okay. So what is a hash? Sorting?
No, not so.
Hash is
It's a key value structure.
so usually function. What kind of function is this?
Hash function.
It's a hash function. Then what is the hash function? It generates hash key. Hash key. Okay? It's a bidirectional or one directional? It's a one direction. Okay? It usually makes the same key value for the same data, but you cannot recover. That is the reason hash key has been used a lot for security, because you cannot restore, recover. Then, what is the example? Still, many of the students cannot imagine what is a hash function, what is a hash key. But if you see this one, you can easily understand. What is this? Modular. So 10 modular by 5. What is that? 0. So what about 11?
1,
What about 12?
2,
What about millions? 1. 1. So modular is most popular hash function. It will. So hash function is that a function to make the very complicated the data to simple. It can simplify the data. So no matter what big size, whatever the number you have, it will be 0, 1, 2, 3, 4, one of this. So each one is called hash key. So you can create the bucket or bin for each. This is called hash bucket. So we can apply the same idea for the join. So for example, here you apply the hash function modular for each record. So this one goes to here, this one goes to here, this one goes to here, this one goes to here. One of these hash key, one of these hash bucket. Then check the inner table. For the inner table, apply the same hash function. Then this one goes to here. Then check the older data in the same hash bucket, same hash key. Is it benefit or not? Benefit. Why? Because you can reduce the search area by even roughly 20%. So narrow down the 20%. You can reduce 80% overhead. It's huge, the reduction. You can get the speed by applying the simple hash key. So this is the join operation using hash nowadays. That is the reason hash has been used a lot for indexing in database. Also, in the security, is there any way to find what's the original data of this? No way. We cannot go back. It's a one direction. So that is the reason we can use such a hash function for the security purpose. So we will continue the rest of the part then next week. So we will, I think we can cover the most of the important part, but next week we will formalize such a complexity. Okay? Like this one. We can formalize the cost function of each processing pattern. Okay, we will see next week.